Manisha Gonda, BTech Computer Science student, E19CSC 237 of Bennett University. Today I am going to explain what is breadth first search BFS is, along with some real world applications and an example.
Let us get started. What is an algorithm? An algorithm is a specific procedure for solving a well-defined computational problem. It is also known as logic. For example, Fibonacci logic, arithmetic logic, linear search, etc. All these programs have a specific procedure or a logic to solve a problem. Let us learn about breadth first search algorithm. What is breadth first search? It is an algorithm for traversing and searching tree or graph data structure. It uses queue data structure, which is first in, first out, or FIFO data structure. Let me explain what is FIFO. Let us consider a queue consisting of some elements. Let us consider 1, 2, 3, 4 are the elements in the queue. So 1 is the first element and 4 is the last element in the queue. As the name suggests, the element which is in the first will go out first. It is just like a basic queue. So 1 will be printed first, and then 2 will be printed, and then 3, and then 4. Let us go to the next point. The time complexity can be expressed as big O of V plus E. Here V are the vertices and E is the edges. We have to know the point that big O of E may vary between big O of 1 and big O of V square. Now let us explore the real-life applications of BFS. Shortest path and minimum spanning tree for unweighted graph. Let me explain what is an unweighted graph. Let us consider a simple graph consisting of 3 vertices and 3 edges. This is an unweighted graph because the vertices doesn't contain any weight. That is, the vertices doesn't contain any value. If we just assign some values to the vertices like this, then this will become a weighted graph. In an unweighted graph, the shortest path is the path with least number of edges. With breadth first search, we always reach a vertex from a given source using the minimum number of edges. Also, in case of unweighted graph, any spanning tree is minimum spanning tree, and we can use either depth or breadth first traversal for finding a spanning tree. Now let us go to the next one. Peer-to-peer networking. In peer-to-peer networking like BitTorrent, breadth first search is used to find all neighbor nodes, which is used to share information without a centralized server. GPS navigation system. BFS is also used in GPS navigation system to find all the neighboring locations. Broadcasting in network. In networks, a broadcasting packet follows breadth first search to reach to all its nodes. In garbage collection, breadth first search is used in copying garbage collection using Chinese algorithm. Breadth first search is preferred over depth first search because of better locality of reference. Cycle detection in undirected graph. Now let us know what is an undirected graph is. Again, let us consider a simple graph with 3 vertices and 3 edges. And this is an undirected graph as we doesn't have any arrows to indicate how the graph is traversing. If we add arrows which indicates how the graph is traversing, then this will become a directed graph. In undirected graph, either BFS or DFS can be used to detect cycle. We can also use BFS to detect cycle in a directed graph. Pathfinding. We use BFS in pathfinding algorithm to help aid robots in movement and in autonomous cars. There is also another graph traversal algorithm known as depth first search, which is like BFS. So let us compare them and find the key differences between BFS and DFS. These are the differences which set BFS apart from DFS. BFS uses queue to find the shortest path, as we discussed earlier, whereas DFS uses stack to find the shortest path. BFS is better when target is closer to the source. Well, you guessed it. DFS is better when target is far from the source. BFS is slower than DFS. DFS is faster than BFS. As BFS considers all neighbors, so it is not suitable for decision tree used in puzzle games. DFS is more suitable for decision tree, as with one decision we need to traverse further to augment the decision. If we reach the conclusion, we won. Here is a pictorial example of BFS. Let us consider a graph consisting of 6 nodes, that is 6 vertices and 8 edges. As we know that BFS uses queue data structure, we'll consider 2 queues, one for enqueuing and one for dequeuing, and then printing the graph. So first we have to choose a root node. We can choose any one of them as a root node. I'm choosing one as a root node. Okay, as we choose one, we'll enqueue one and then see what are their neighboring nodes. Here 2 and 3 are its neighboring nodes. So we will now dequeue 1 and then traverse 2 and 3. We enqueue 2 and 3 and we can now consider any of the node within 2 or 3. As it is a queue data structure, we have 2 in the first place, so we consider 2. So we will search for the neighboring elements of 2, which are 4 and 5. So now we traverse 4 and 5 and then enqueue them. We dequeue 2 and 3. After that, here we choose 4 as the next node and then enqueue 6. Hence all the graphs are traversed. Now we can print the final result. The final result would be 1, 2, 3, 4, 5 and 6. Now let us learn the code. Over here we have to find the shortest path back to the root when a graph G and root node are given as inputs. Let us consider the pseudocode. First we consider BFS as a method which has 2 parameters, which is graph and the root. Let us consider a variable q as a queue and then define or label root as discovered. Now we enqueue root in the queue as it is already discovered and traversed. Now let us traverse. We'll consider a loop and we'll run the loop until the queue is not empty. Now we will dequeue the elements in the queue into another queue V. As V is our goal, we will print V. Now we will traverse the neighboring nodes, which are the adjacent edges. As V is the node, we will traverse the adjacent edges from V to W, and then as W is not traversed is not discovered, we will go to W and then we discover it and label it as discovered. Now we will enqueue W in the queue and then this will be V. This process continues until we traverse all the nodes in the graph. After we have traversed all the nodes, the queue will be empty. Then we will print the result. So the goal will be we will print the shortest path back to the root. To summarize, we have seen what an algorithm is, what BFS is and its application in real life, and then we saw the difference between BFS and DFS, and then a pictorial example of how BFS work, and lastly we learned the pseudocode of BFS. Thank you. Have a great day.